what we're going to do now is actually prove that theorem. So sometimes to prove theorems, you have to add a line or a segment or array to a given diagram. That's going to be called an auxiliary line. And so in order to prove the triangle sum theorem, then we're going to use this auxiliary line, which is here in blue across the top. And that auxiliary line, if you notice, is parallel to side AC of the triangle that's given to us. So given triangle ABC, and you will see some angles just labeled. It's okay to label angles. We need to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees, because the triangle sum theorem says that the sum of the measures of the interior angles are 180 degrees. And so I gave you a hint. Draw an auxiliary line through B that is parallel to AC, and then show that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. And you're going to use alternate interior angles to do that. Now, I want you to actually take some time and take a moment to try to figure this one out, because I think that when you prove a theorem, then it kind of gives you a better understanding of why that theorem is, because now you understand all the details behind it. So go ahead and pause, prove the theorem, and then when you come back, we will do it together. Okay, so as you can see, I already went ahead and set up the proof so that we could have it ready, and hopefully this is enough space over here. So we always have to start with the given, and all we know, and I want to switch up the color here. Let's make it green. So all we know is that we have triangle ABC, and that's given. And even though that seems like we don't need to say that, well, we need to say that because we need to establish that ABC is actually a triangle. Okay, then what we're going to do is we're going to draw BD. So that's our auxiliary line. Parallel to AC, segment AC. So this is 1, this is 2. Parallel through segment AC. And remember, this is going to come from our parallel postulate, because our parallel postulate says that through any point not on the line, we can draw a line that is parallel to that line. So if B is the point not on AC, then we can draw a line through B that will be parallel to AC. Okay? All right, next. So next we're going to say that angle 4 and angle ABD are a linear pair. And that's going to come from our definition of a linear pair. Okay, so this angle and then this whole angle are a linear pair, because a pair has to be 2. So we have to say 2. And then after that, we can say angle 4 and angle ABD are supplementary. And that, of course, is by the linear pair postulate. Okay. Next, we can say that the measure of angle ABD is equal to the measure of angle 2 plus the measure of angle 5. So this angle is made up of 2 and 5. And that's going to be from our angle addition postulate. Okay. And I'm out of space over here, so what I'm actually going to do is kind of start over here on the other side. Let's see. I wanted to pull this over. So I'm trying to pull this over so I can have a little more space, but still see the image, because we still need the image. So hopefully this will work. I feel like, okay, so let's see, hopefully this works. Okay, so now that we know that 2 and 5 make up ADB, then we can say that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. And we did that because we did some substitution. And that is actually going to be number 6. So remember, and I'm going to go back over here. Over here, we said that the measure of, we said that angle 4 and ABD are supplementary. I messed up because in the middle of that, I should have put that, we'll call this 4.5, that the measure of angle 4 plus the measure of angle ABD is equal to 180. And that's going to be by your definition of supplementary. And so then that would have given me a right now to substitute over here, because in place of ABD, I have angle 2 and angle 5 because I've said that they're equal. Okay. So then after that, for number 7, I can say that angle 4 is congruent to angle 1 because this is 2 parallel lines cut by a transversal. And so those are going to be alternate interior angles theorem. Okay. I can do the same thing on the other side, and I can say that angle 5 is congruent to angle 3 because here would be my 2 parallel lines and here would be the transversal. So those are also going to be alternate interior angles. Okay. And so then if they are congruent, then their measures are equal. And so that's going to be the definition of congruent. Let's do that like that since my writing is a little off. All right. And then lastly, well, almost lastly, but lastly, I'm going to go back up to number 6 to end up with my number 9. And I can say that 180 degrees is equal to, instead of angle 4, I'm going to put angle 1 because they're congruent in line number 8, plus the measure of angle 2, plus, instead of angle 5, I'm going to put the measure of angle 3. And I was able to do all of that because of substitution. And then I'm done, because that would show that angle 1, 2, and 3, which make the triangle, is equal to 180 degrees. And I wanted to show you this because I wanted you to fully understand how proofs work and how each piece of information that we learn builds on the next. Because I'm sure you're probably wondering, why do we need to know alternate interior angles and parallel lines? That has nothing to do with what we started with, talking about angles and segments, and now triangles. Where does that go in the middle? But this right here shows perfectly how they mix together and how you need all of the pieces of the puzzle to build on top of each other to fully understand all of the concepts. So let's keep going.